Welcome to the Dev Banner. This is Eric. This video is how to deal with interfaces. Explain them, what they are. As you can see, I have this question, what is an interface? Now, when I started developing with Go, I learned what interfaces were, and didn't think I'd ever use them. And because it felt like if those who have ever done object-oriented programming felt a lot like abstracted methods and all that stuff with inheritance. And so I'm like, these are not anything I'm ever going to deal with. And I didn't kind of get a grasp of them, but over the years I've come to appreciate interfaces and what they do to help you as a developer. So what is an interface? I have here a definition or a signature of a set of methods on a struct. Or it describes exact methods of another type must have. And I'm going to explain a little bit more to that later in this video, but I want you to think of it as like a contract. That if you have an interface that defines some methods, then you can use a struct that has those same methods in the place of that interface. And so let's go over the first. There's two real instances of the word interface that is kind of used in two different places within Go. And we're going to go, if you've ever listened to any of my other how-to, I've made some programs and just some example codes. And so let's go to basic, and we're going to start with this. And this is the first major way that you'll see interface. And I'm creating this type called interfacer. Now, the people from Go have kind of a standard that anything that's an interface should start with or end in the ER or an OR or whatever appropriate name. So in this case, I just called it interfacer. And with the keyword of interface, and then here you would, say, run, and maybe that sends back an error or whatever. That's that signature of methods that this interface is describing for anything that wants to be associated with that interface and being used as. And I'll explain more of that. So let me just get rid of that. And I just created this struct called vanilla, and it has, as you can see, it has a field called favorite flavor, and is vanilla your favorite flavor, true or false? And what basic is doing is just we'll instantiate the vanilla and set it to true, its favorite flavor, and then we're going to be passed into do something. And we're in place going to say, oh, I want that to be of a type interface as that receiving argument. And in this case, all works out okay because vanilla, or interface I should say, has no methods, it has no method signature. There's no contract. It's open-ended. There's anything at this point in the Go language could be passed in as this argument. So just to prove, we're going to go build and interface, and this should come back and says is vanilla my favorite flavor? Yes. Now at this point you're going to say, okay, well then why send it in? And you could, the right thing to do would just to replace this with a T, %T, and then you would be P. But here's the problem. favorite flavor is not part of this interface. The interface doesn't have any fields, it just has methods. And so this is the problem. This is something that you have to deal with if you're going to use an interface as this type, like in this argument. So I'm just going to undo that just so that we can keep it and it doesn't error out on us. And so let's talk about casting. Now, I guess cast is probably the best word for it. I'm just going to close these really quick. We're doing the kind of same thing. We got this pie. What's my favorite flavor? In this case, we're going to give it with a string. And so I like peach pie. I like pie. So peach is one of my favorite when it's in season. Anyway, so now I'm going to cast something. And so cast might not be the right word, but I think if you've done any kind of programming, you understand that you're taking a type of something and casting it to something else. And in this case, we're, instead of making a type and declaring a type and having it be an empty interface, we're actually, this is another common way that you'll see throughout a lot of Go code, is this, hey, I can take anything in this as an argument. And it's done by just doing this interface, curly brackets, open, close curly brackets. So let's look at cast something. As you can see, I'm not doing the same thing that I did with the other method, and that is creating a type of interface and then setting it with no signature. You can actually just use this interface, open and closing curly braces, and that becomes that. And you see this all through the Go code, and you'll see how this works here in a second. But it's equivalent to what I was doing the first end without actually declaring my own type. And so we're doing the same thing. But here's the casting part. And like I said, the cast is kind of a loose word, but what you do is you take what your interface is and you do a dot, and then within parentheses, you cast it to the type that you think it's going to be. Now the problem is you can be any kind, as long as it knows about that type, you can try to cast it. But the problem is if it's not the right thing to do, it will actually panic and your application will fail. And then from there you can finish the dot notation. So at least from a Visual Studio standpoint, it says, oh yeah, I know a favorite flavor. Let's go ahead and do that. And that is kind of how you cast things into with an interface. And so by using this, once again, this basically says any type can be sent in as this value. So let's take in, for instance, I did it with V right here, right? And then we're going to check. We're gonna look at this one now. So here's what's really awesome. There's this great little pattern that they've given you, the guys from Go, and you can just go ahead and cast it. And if it casts okay, then it will come into this method or into this variable. And it also, you can add this. You don't have to do this. You could just do that. And this ends up being a Boolean. And if it doesn't cast successfully, then you know what? Then you can go ahead and check to see if it's done. And this won't panic, as you'll tell, because I'm now going to try to cast that V, which is a pi, and this should come in here and says, B is not an int. And then the second one, by sending in 10, this should print that one. So with that, you can do a lot of more complex decision making and making sure things work. And this is something that you can do. You can make an array of interfaces, and you can set all these different types, right? And then you can go through and then you can say if, else, switch, whatever you want to do to check, and then this should print all of those based on there's an int, there's a float, a string, boolean, and I even made my struct, which I could have other methods on this, but it's an empty interface, so even just a plain struct or even a struct with some methods would fall into this interface. And then if I don't do anything, then I'm just going to print something. So this character, rune, whatever you want to call it, it's a rune, but it's a character because it's just one ASCII code considered, but it's a rune. That's what they call it in Go. This one should fill here. So let's go ahead and do clear and build it and run it. And you'll see that my favorite pie is peach. So that seemed to work. This cast check, B is not an int, which is a pie, but 10 is, and I'm just printing 10. And then so you'll see that each one of those, and I'm just printing off the index of this array to prove that I'm going 0 through 5, and you'll see that all of these went through these proper decision if statements correctly. And the last one didn't find a match, so that's what it prints. So there you go. That's kind of the cast, and we'll now look at what I talked about earlier, or alluded to earlier, is the method signatures and how you can use that to like limit what you can throw, what you can associate a struct with an interface. So let's go to animal, and we're going to look at that this interface. These are the signatures that I want. I want a walk and a talk. And I'm just going to go ahead and create 3 different structs. And by associating that with this is you have to create methods. Now, this is a function. That's the proper name for it. But if you have a receiver of a struct, that becomes a method for dog. And if you supply both of them, then what Go does is says, hey, dog, wherever I see dog, and if it wants to be of this type animal or this interface animal, as long as it has both of those, fulfills the contract, then, or the signature of the methods for that interface, then it will infer the usage in that at compile time. Because if you don't, then it won't compile. And I'll show that here in a minute. So really, this is I'm going to create an array of animals, and I'm going to add a dog, cat, and duck to it by instantiating those. And then I'm going to go run through those, and I'm going to tell it to walk and talk. Now you'll see that dog if dog didn't have talk, then the animal couldn't say, oh, I'm of type dog, go ahead and run this function, if it didn't have this. So that's where the beauty of interfaces is that once it knows that contract, then it can infer it and things are just going to work out. So you'll see that I've done that with both the cat and the duck. So if we go ahead and run that, I did not replace animal. Let's go ahead and do that and run that again. And then you'll see that we are going through and hitting each one as it should be. And so that's kind of how the signatures work. Now you're going to say, well, that's kind of cool and all, right? But there is some really great things that you can do with interfaces, and these things do come up. You'll be able to use these kind of patterns where needed. But the real strength is the things you can do and program when you maybe interface with a third-party service, for instance. So let's say that you create an application that's just sitting there, and every day you need to go out, talk to this service, and get some piece of data and push it into a database. They have an API, you have the credentials, and you just run this thing in the background on some server, and you're connecting to that interface or that API. So in order to program that and to test it, maybe you're testing locally. Well, what if you don't have necessarily real access to a development for that API, but you have access to prod, and you've been told not to hit prod. Maybe another team's going to do it, or maybe they have the credentials, but you got to at least make sure that your code works. You can use the interface to help you abstract that layer, which is a third-party layer. So that's my next piece to this little program that I wanted to show you. And the pattern that I've come to know and use quite a bit is called dependency injection. And so I'm just going to call it injection. So I'm going to go ahead and uncomment those out. So I have this method called injection, and actually I've put it in its own folder, and I've organized the files to kind of represent how I kind of do my APIs, because I use that pattern, this dependency injection pattern, quite a bit in my code, especially when it comes to when I write my APIs. And I think it's the best reason why, and this I will show you, but it's the best, help me understand interfaces so much better by using them, and just light bulb clicked on and went, I get it, and it took a little while to get there. So let's look at one of the things that I set this project up, and I like to think about it as layers. In an API, you have your protocol, whether it's your HTTP or your gRPC, kind of that comes in, and those are your protocols. The packages and how the data is coming into your API is different depending on whether it's HTTP or gRPC. And so what you can have is you can have two different files here that calls the same logic, and that's kind of what I do. And what the whole idea is this ends up being a struct that you pass down to your logic. And so if you think of these as layers, this is your first layer, and it organizes the data coming in as that particular format, puts it in a struct, and then you come down to your logic layer. And your logic layer is just basically saying, is the data in this struct okay? Do I need to transform it for any reasons whatsoever? Maybe put it into a new struct or whatever the case may be, but this is your logic layer. And then I'm just depicting this object here as an interface. And the interface is saying, okay, where do I go next? And depending on how you inject your interface, depends on where you want to go on the storage layer. So you'll see that I have a DB or maybe a file. Maybe your system is one of a database, and maybe another same application you might want to say, no, I want to push this to a file. And I'll show you this here in a minute, but this, you can inject your interface through code to say, depending on which one, this struct might be a database or this might be a file, and run its methods. So let's come back to here. Let's go to main, and right here you'll see that I'm creating this logic. Now I'm just telling you right now, I'm not doing anything with this. It was way past the scope of trying to do a true HTTP server. So I'm starting down here, but the logic is still the same. Once again, if you think of these as layers, you'll understand where I'm coming from. So logic-wise, I'm going to create an interface for my storage. And this is where the dependency comes in. Meaning, I need a storage that has a save method. As long as it has a save method that takes a user and gives back an error, then I can use whatever struct to fill that. And so this is my user logic, and it owns a user storage adapter. I use the word adapter because it fills the ER, and it is kind of an adapter. It is kind of, this is going to adapt to whatever you throw into it. And so, and then I just, by name of what the entity name is, and a storage, whether it's storage or whether it's your logic or a manager or whatever you want to call it. And it takes that. And so when we create a new user logic, we're going to take that in and we're going to send back a pointer to this guy right here. And that's all done through sending in you, this user storage, which is that field. And that's it. You've now done dependency injection. And really all the save is saying, yep, I need a first name, I need a last name. If not, I'm going to return, and that would pass it back up to here, and then you would display that to the user however you wanted. In this case, on this API, you would HTTP maybe send back a JSON with a field saying error, you need the first name or you need the last name. gRPC, you probably do the same through the protobufs as you determine what those protobufs should be and those responses. And then coming back to our independency injection, then we say, okay, well, the receiver for this method is just a user logic. And so you're now calling this interface's save, just like we did with animal. And at this point, we're going to send in the user because that's what it wants. Right? Simple enough. So my storage layer, I'm kind of doing the same thing. I don't have an interface here because I don't have anything that's dependent on the storage. Now you might, maybe you like, okay, once I store this, I'm going to email, which is a third-party service. And you might want an independency injection for that email. And you would put it here. But in this in this particular case we don't, but that's what's great about it. Then you'd be able to test it, run your logic, and you can mock a layer, and I'll show you how to do that here in a minute, to say, yep, I sent an email, without really sending an email, and without really worrying about sending an email. And so in this case, when I save, I'm just going to produce this code, or this print line, okay? And so let's go ahead and run that. Let's make sure that we are running it. And I'm just going to clear, build, and run. And you'll see that I'm into production code. Now let's see how we hook that up. So back in main, I created my new storage. So from here, you're saying I'm gonna create this thing, and then I'm gonna inject it into the layer above it. Eject it into layer above it, if you had an interface right here. I'm creating the storage, and then when I create the new logic, here's that it's expecting an adapter, this user storage adapter. Well, storage has a save function that takes a user and returns an error. It fulfills that contract. And then I'm just going to create a user, and then I'm going to say, hey, logic, go ahead and save that. So, and that's basically it. So what's really nice is you can now, like I said, you could mock, and I'm just going to create something here, and you can say, okay, well, now I'm going to mock. And those mock could be anything. It could be of your own devices, and I'll show you a way to do it through a program that the Google people have created. But let's say that I have my mock. My mock looks pretty much like the storage, but I did not give it the method. So let's see what it looks like if I try to do that. So I'm going to get rid of, I'm going to comment storage, and I'm going to do mock my mock, and I'm going to actually, what is it? Excuse me. New mock storage. Let's do, you could do either one, and we're going to do mock. Now you'll see now that you get the little squigglies. There's a problem here, and this is when you compile it, before you compile it, or if you're not, having IntelliSense, when you compile, you'll get this message: mock, my mock does not implement user storage adapter missing method save. So to rectify that, I come over here and I do func, and I'm just going to say my mock, and that now makes it a method, and I'm going to save, and I'm going to take a user, and I'm going to send back an error, and in order to do that, we're going to send back nil, and we're going to go print line in my mock. Okay, so at this point, now you've gotten rid of that because you've fulfilled the contract, and now you can go ahead and run this, and this is going to be my mock. This is what's great about this pattern, is you can totally mock, if you want to, any kind of third-party service. And so if you want to say that this is kind of a third-party service, which it is, sometimes your database is somewhere else or whatever, you can do this in the dependency injection and get you what you need. Now what we're going to do is we're going to do a mock gen, and I'm going to show you that and you probably saw this. So if you come over here to logic, you'll see that I have this comment. Mock gen is just a project by the Google people, and if you go look for it, it's underneath, I think, google.com, GitHub, you can actually create your mock file for you based on this interface right here. So this whole program's job is to read this interface of the source file, right? I'm in logic.go, and I'm going to tell it where to go after it does it, and then I'm going to tell it which package I want it to be in. So I've already ran this once, but this is a really neat program, and I'll show you why. So what it does is when you run that mockgen program with those parameters, those arguments, you get this file. And once again, it has a save function that takes in a user and brings back an error. And so this creates it for you. And this is really great. And so what this does is this helps you create tests. And because you don't really care what this thing gives you, you only care about testing this logic. And then what they've done is they've given you some helper functions like, hey, maybe you want to bring back an error so that if logic gets an error, maybe you need to do something special. And you can test that logic without caring whether it's a database or a file or maybe even your own mock. This is a great little tool in the Go ecosystem. So for instance, I've created this test file, and this is how you set it up. You have to make this new Go mock new controller, and you basically create your new mock user storage adapter, and you give it the controller. Now this video is not about getting into this, and maybe that's a future video, but I just wanted to show you that you do the same thing. You create a new user logic, which we did before in our main, and you supply it the mock logic, and you call it. Basically, this is just saying, I'm expecting this call. So if I give it Albert Einstein as the first and last name, I'm expecting that to go and be called, and it's going to substitute and say, yep, I'm going to come back as a nil because everything was great. And I don't care what I'm sending it as a user because it's not going to be using it, right? So they give you this any, which is nice. I use it all the time. And then you can just call it as we did in the main.go, and then see what it gets. And so if by chance you have problems, then you can print out your error messages. So let's go ahead and run the test, and I'll show you how it works. So you can see my test ran and there was no issues. This is not necessarily a video about testing, but you'll see that I'm using this mock and then using the interfaces to inject a mock in there so that I can test this logic. And that's pretty much one of the benefits of interfaces. I hope this cleared up a lot of things and hopefully giving you some new ideas on how interfaces are used and how you can use especially the dependency injection. Thank you for watching. See you next time. Please subscribe to the channel and make sure notifications are turned on.